Hi, everyone, and welcome to another great presentation focusing on opportunities of AI to drive business value. In this session, Laya Shamgah, data scientist at Lowe's companies, will talk about how visual data is used in the retail industry to solve various problems, particularly in their stores.
Hello, everyone. I'm super excited to speak with you today and to talk to you about one of the most fabulous topics in the world of data science, computer vision. First, I will give a very brief introduction to myself, and then I will talk about the computer vision techniques and the retail specific problems and challenges. And finally, how we use computer vision in retails to solve our problems. So I am Laya Shamgah. I joined Lowe's a little over a year ago. Before that, I was working in a robotics research laboratory as a PhD student, and we tried to get all these cool achievements in the computer science field and apply them to our problems in robotics and autonomous vehicle domain. So then I did a summer internship as a data scientist, and I got very fascinated by employing the same techniques and method in the business domain, which honestly, to me personally, feels more humanized and interesting. So after graduation, I decided to join one of the biggest companies in retail to develop all these products using machine learning and deep learning to solve all variety of business problems. And today I will be sharing my knowledge and experiences during this journey of using computer vision to solve problems in retail. Actually, computer vision is a very fast-growing technology, and it's also growing in popularity very fast. And the intention in using computer vision is also becoming more and more popular. So I will talk briefly about the history of computer vision in the next slides. So the first thing I want to talk about today is computer vision, especially to the ones who may not be very familiar with this particular domain in data science and machine learning. But first, let's ask the simple question that what is vision? What exactly does it mean to see? Vision in a biological creature helps them to make inferences about the world. They use vision to find food, to differentiate between a toxic plant and a safe plant, to find a prey and avoid predators, to find shadows to hide in, or even to select a mate. Sometimes this inference leads to an immediate action, and other times we just store the information and act on it later. So the computer vision is basically the science of giving computers or machines these kind of abilities. Vision capability to see. Computer vision to mimic human vision capabilities. So they can make this kind of inferences, they can make decisions like us humans, but without our flaws and biases, the problems that we might have during those inferences. So let's talk about the journey of computer vision. Computer vision has been around for almost 60 years now, so it's relatively new compared to the other techniques in data science. But the first attempt to give machines the vision capabilities was called hierarchical approaches. And it happened in the early 60s, I believe. So the idea then was, in order to understand, to inference visual information, we need to process them in a hierarchical manner in several steps. But it was in early 60s that classical computer vision was born. And they basically were some simple matching techniques called template matching and feature matching. Template matching techniques are basically sliding windows or filters for object detection and classification. So for a given template of an object, we can look in hundreds of windows to find the exact match of the template object in the source image. But this didn't actually work very well in the real world because of all these changes you might have in the size, the light, or even the angle between the template and the source image. So people started working on feature-based techniques, and the idea was basically to extract some features, they call it key point, and find the matches of those key points in the source image, between the source image, between the windows and the template. But it was in early 2000s where machine learning inspired computer vision was born. And later, the famous rockstar models in this field like CNN, RCNN, Faster RCNN, YOLO, you only look once, were introduced. And finally, with the use of transfer learning and all the powerful pre-trained models that are available right now, for example, VGG16 and VGG19, EAST model for scene text detection, and ResNet, and much more soon to be available models, it is now easier to adopt this very difficult technique to develop models very easily and solve various problems in the business. Now let's talk about the retailers and specifically the stores and their features and, more importantly, their problems. So the most important question in each project is what you want to see in a store and why and how. So first, let's look at the layout of the stores. Well, at least most of the stores in retailers. So in a store, we might have the selling area or display area where the customers can walk around the aisles or the display area, look for what they need or what they like, look at the items and check their prices, and so on. Then we might have fitting areas for some fashion retailers. We have the registers, which is a very important section in the stores. And in some of the stores, we also have self-checkout area. And then we have the warehouse in most of the stores. And the entrance of the stores is actually very interesting these days. So we have all these areas in stores, and each has different objectives, different problems, different challenges. So the first thing we need to know is what area the problem is related to. And the next thing I want to point is the object in the area. What we want to scan. Is it the products? Is it the shop? Is it the customers? What exactly we need to see in those areas of the stores. And finally, the last important question is how we want to see that object. Well, data comes from sensors, and the important question is what sensor we want to use to obtain that data for us. Are we going to use cameras or drones? Do we want to take pictures or videos and so on? Honestly, the most important data from stores that retailers have is the transactions, which are usually obtained by some software system. And we don't have enough images data from the stores. Right now, we have some images, but it's not, it hasn't been around like transaction. And there's a lot going on in the stores that we don't collect any data from or not enough data from. So the important data in the stores that we can use images and videos are the inventory, the stock, the customer behavior. This is actually easier to track in e-commerce than the stores, because stores. The store traffic is also an important issue especially during the COVID era, because we need to limit the number of customers in a store based on some regulations that government impose. So the question here is what data sources we have. What is a good data collection method? And as I said, do we need cameras? Do we need an app so employee can take pictures from a specific part of the stores and use a drone? What is the best solution in terms of speed, cost, coverage, and so on? So based on what part of the stores we want to observe, the answer to these questions may change. After we define the problem, the location of the problem, and the object and the data source, now we should start asking some questions and find the best answers to these questions. So the first question is, now that we have the data sources and the collection procedure, how we want to store them? Do we want to use some cloud services? Do we want to pay for those services? Should we store them on the store servers, or we want to send them back to the headquarters? The second question is about processing. Do we want some kind of real-time processing, or batch processing is a better way for us to go forward? How frequently do we want to do the analysis? Are we going to do it daily, weekly? I don't know, in milliseconds? This is a very important question, actually. And a lot of things depends on the answer to this question. And finally, the most important and challenging part is modeling. So the questions are, what kind of model do we need? Do we need a simpler model, like some kind of image classification models, or we want object detection models with localization capabilities? Do we, or even we may need a visual query detection to answer the questions like how many samples of this object we can find in the store, or for example, how many samples of this object that has this feature you can find. For example, find all the red shirts in the store for me. This kind of question. So we should go ahead and select the model category that we might need to solve that problem and develop an actual model. Honestly, most of the time, the transfer learning is the solution. VGG16 and VGG19 provide great feature extraction for any image that you can use. And there are tons of other pre-trained models out there as well that you can fine-tune for own use cases. But if you need a model specific to your data, then you need to go ahead and annotate the data for training, or even for transferring. You need that annotation phase. And finally, the final step is to deploy the architecture in the stores or anywhere you want to do the processing. So here I want to talk about some examples of very common products that most retailers already have implemented in their stores or they have been developing and testing. One of the most important challenges in retail is inventory tracking, smart inventory tracking. A lot of retail companies are using computer vision these days as part of the solutions. You might have heard of mobile robots that operate in warehouses and move the products around to increase the speed of filling up the empty shelves and also decrease the risk of personal injuries. Or some robots in the stores that scan the shelves and look for the updated inventory information. For example, they look for the empty shelves, what products are missing, and how many items you need to put in that shelf, those kind of things. Some stores use drones to scan the shelves and products and update the inventory, which using drones and robots has a wide range of challenges. So the second important project is visual search. This is also very important product to improve customer experience in the stores. And most of the retailers have already implemented this on their app, but this is also a very challenging computer vision problem. And it has many aspects because it's very specific to your own products. And it's not easy to use pre-trained models in the system. So there are always rooms for improvement in here. The third product I want to talk about is in-store navigation. This is another product that can help the customers have a better shopping experience in the store. All of us have already experienced some confusion while looking for some items in the store and wandering around the stores, crying for help from the associate and getting frustrated. Well, a navigation feature on the store app might be a great tool to help all the customers to enjoy their shopping trip and save some time. The other product is this product in particular can help the customers of home improvement stores like Lowe and other retailers that sell home products is adopting AR/VR technology for 3D space planning. So, of course, there are many other products that use computer vision techniques in the stores. Even us, the data scientists at Lowe, have tons of other projects that are benefiting from computer vision. For example, the most recent one was people counting using the entrance camera to limit the store traffic in accordance with state laws for COVID. So I want to talk about the challenges we usually face in this kind of projects. But please keep that in mind that in this field, there are usually more opportunities than challenges. And usually there are more solutions than problems. And we as a team are always communicating with different parts of business, different departments to identify the problems that we can solve with computer vision. And sometimes they don't even know about this problem. They don't even know they exist. And more importantly, they have no idea that computer vision can solve this problem in a more efficient fashion in terms of speed, accuracy, cost, so many things. Anyway, the most common challenges that I want to bring to your attention today are in these three categories. Data preparation is always the most important one. As I mentioned before, deciding on how to get the images or videos, where to store them, and how to transfer them to the server or cluster or anywhere that the models are running is a very important step. Then the speed of analysis and processing is a challenge, especially if you want the real-time processing of videos, but you don't want to sacrifice the performance of the solution. You don't want to sacrifice the accuracy. Most of these challenges are considered while designing the architecture of the solution, which is actually a collaboration between product managers, data scientists, data engineers, and other team members. The other important challenge, which is specific to data scientists, is, and it usually prevents us from reaching a high accuracy. And by high accuracy, I mean 80%, 90% accuracy, is that all these images and videos in the store are from natural scene. And speaking of natural scene, I'm talking about complex background, noises, all kinds of noises on the images and videos. The lighting is usually a challenge in the stores with all those lights on the ceiling and geometrical distortion in the images. And more specifically for text detection, there are more additional challenges like different fonts, handwritten text, non-English words maybe, and so on. So most of our efforts as data scientists is on processing images and training powerful models with novel architecture that can address these kind of issues. So as I mentioned before, the overall objective of any project in this field is improving the customer experience. This is the most important objective of all kinds of projects in retail. We want to improve the quality of customer experience online or in a store from start to end. And we want the customers to have a very smooth and fast journey in our stores. And all of our efforts in data science is aligned with that objective. And the other objective is usually to reduce the cost and time spent in the store operations and improve the loss and accuracy of the store. So I and maybe everyone believe that computer vision is the key here. Even though we are still far from the ideal solution, the ideal data sources to capture and represent the stores, what's going on in the stores for us. And we also from developing intelligent but different models that can give us what they want, but with fast-growing technology and broad researchers in this area, we are very optimistic or even confident that we can reach this far destination using computer vision very soon. So I wanted to thank you all for listening to my talk today. If you have any questions, please feel free to ask them in the Q&A session.
That was Laya Shamgah, data scientist at Lowe's Companies, talking about opportunities of computer vision in retail stores. If you're interested in learning more about how AI can help the retail industry, please subscribe to our channel below.